let's start by going over number 3. We'll solve it explicitly, just like our opener, where we first have to get y by itself, then we'll take the derivative, and then we'll move to implicit to compare our answers. So again, I'm getting y by itself, so I'm bringing everything over. Solving for y, I'm going to take the square root, rewriting y, so we can see that power rule using that 1/2 exponent, similar to our last example. And now I'm ready to take the derivative. I have y explicitly expressed in terms of x. So when I go to take derivative of y with respect to x, I have dy dx is equal to power rule, multiplying down our exponent, 1/2 times that quantity using our chain rule. We have 10 minus 3x squared minus 2x, all to the negative 1/2 power. Again, applying that chain rule, linking in derivative of our interior quantity, we have negative 6x minus 2. So we're left with dy dx is equal to, distributing our 1/2, we have negative 3x minus 1 all over the square root, 10 minus 3x squared minus 2x. So again, we found our derivative using explicit approach, what we've been doing the past few weeks in chapter 3 and 4.1. And now we're going to compare it to implicit differentiation. Again, thinking y is a function of x. So if we rewrite the original problem, we have 3x squared plus 2x plus y squared equal to 10. I'm going to start directly by taking the derivative. It avoids having to solve for y. But I have to remember y is a function of x, so chain rule may apply. So I take power rule, 6x, derivative of x is 1, plus derivative of 2x is 2, applying power rule, 2 times the quantity of y, but we know y is a function of x, so we have derivative of y with respect to x. And again, after you do all that, don't forget derivative of a constant goes to 0. So hopefully we made that first move. Watch that 10. That's a common mistake I see, or just leaving off our dy dx. At this point, we're going to solve for dy dx by bringing everything over. Again, we're starting to see parallels to what we had explicitly. Solving for dy dx, I'm going to divide everything by 2y. And I get dy dx is equal to, simplifying, negative 3x minus 1 over y. And we can quickly see if we were to substitute y, which was the square root of 10 minus 3x squared minus 2x, our derivatives match. And again, when we're using implicit differentiation, we don't need to substitute back in. I'm just trying to prove that in our examples for us right now. All right, so folks, we're going to do a couple more examples. Remember, make them interactive with me. So as I start example 4, make your first move after me, and then eventually pause the video. See if you can make the first move, then press play. Make it as interactive as possible. But again, we want to remember, since y is a function of x, chain rule may apply. So we have y squared is equal to x. Again, from here on out, I'm not going to show explicitly. If I saw a problem where y wasn't expressed solely in terms of x, I would start to bring in implicit differentiation into my mind. So I'm going to take derivative of the left side, derivative of the right side. So I have 2 times the quantity of y times the derivative of y with respect to x is equal to 1. Again, 10-second check. Make sure you see a dy dx show up in your paper at that point. Otherwise, it's never going to show up. That's our calculus move. So now we can solve for dy dx, and I get my derivative to be 1 over 2y. Again, one thing that happens with implicit differentiation is often our answer is going to be having both x and y in terms of our derivative. Right? Our derivative formulas are going to be obtained using variables both x and y often. All right, let's look at number 5. Again, I would pause the video after you write it down, try it on your own, and then compare so that you're not just watching. Watching isn't the most appropriate way. I've made the videos to help you and not leave you stranded with the problems. But now you want to pause it, try it on your own, and then pick up where we left off. All right, so I'm going to try and find derivative. Y is not in terms of x. It's not expressed explicitly in terms of our independent variable, so I'm going to jump right into my implicit. I see 2 times y, which is 2 times the derivative of y, dy dx. Y is a function of x, equal 2x plus derivative of sine is cosine x. Again, basic kind of sum and difference rule over here, keeping in mind y is a function of x. To solve for my slope of a tangent line, I have dy dx is equal to 2x plus cosine x Again, I'm thinking algebraically to get dy dx by itself to divide by 2. All right, and then let's move it over for number 6. Again, I would write it down, pause the video, try it on your own, and then compare. And anytime you're struggling with an example, turn and talk to the person next to you. Have that conversation as if we were here together. So we have 2x cubed minus 3y squared equal to 7. Again, make your first move on your own. That first move is the calculus. So I'm going to apply power rule. I just do 2 times 3, 6x squared. Derivative of 2x cubed is 6x squared. Derivative of x times 1. All right, we're seeing that same thought of chain rule, but the derivative of x is simply 1. Here I'm going to apply that same knowledge. 3 times 2, I have 6y. But the derivative of y does not assume to go to 1 because y is a function of x times dy dx. Derivative of a constant is 0. And watch that 7. Those sometimes just keep following along. I mentioned it almost every single problem. Then I'm going to solve for dy dx. I get negative 6y dy dx. Thinking algebraically, how do I get dy dx by itself? Dividing by negative 6y, and I'm left with now the slope to be x squared over y. All right, folks, I'm going to put up number 7. It's kind of the most complex example that you're going to try right now. So you're going to try it on your own, and then you're going to compare with the video you'll find on Canvas. And once you have number 7 compared, you're then going to try 8, 9, and 10 on your own and compare them to the solutions that you see on Canvas and working with your partner. So we have x squared minus 2xy plus y squared equal to 4. So again, you're going to pause this video and this one and try it on your own, and then pick up the last one to go over example 7. Good luck.